So I'm drilling the cross hole that I'll be tapping with the 1/4 NPT tap to meet up with the hole that's the inlet to let all the air out into the vacuum pump. In situations like this where the table's almost all the way down at the bottom, I've got maybe another couple inches I could go. I found that it's kind of nice to use like an ER32 collet to hold the drill bits because it's got a lot smaller profile fit than does a a drill chuck like the large, this guy, Albrecht. You can see this guy sticks way down by comparison, so this helps me get out of having to mount this part on like the side of the mill, like sticking off the back and changing the angle of the turret to get there. I'm gonna pre-drill 1/4. My table's all the way down, so I can't fit a full-size drill. So we went with the next size up that I have a stubby in. It's a 64th larger than the actual tap drill. It shouldn't be a problem. Just means the part, since this is tapered, the NPT is tapered. It just means it'll go in a little bit further. Should be okay. Oops. As an interesting side note, this is a 11 to 12 millimeter collet. The 1/2 inch would not quite go down to this size. It wouldn't reach. So I had to use the metric, which is a tiny bit smaller, and it tightened up on the drill bit perfectly. And actually my tapping machine can handle NPT taps, but I'm doing this one manually anyways. Yeah, it's getting tight already. I think that'll be perfect. I think we're good to go. So all these corner radiuses here, we need to get those, do those next. And that will finish this bottom piece completely. Setting up a rotary table. To find center, I keep the bolts loosened. I unscrew this guy off of here. Put this in a 1-inch collet, screw this on here, and just drop it down the center. That gets it within a few thousandths. So I'm going to finish dialing that in, and we'll get this guy centered up and get our 0 point, and we'll move on from there. We decided on going with a different fixture route. This will be by far the largest piece of material I've ever turned. Not that that's very impressive. 10-inch diameter, 2-inch thick chunk of aluminum. Yeah, so we're going to face, and we're going to turn down the side just to get it all concentric. The outside is pretty rough. It doesn't really matter, but I want to be able to find my center point easily using either the outside or the center piece I put in. So I'm going to try and square it up, as it were. So in order to get the tool behind this part, I had to actually come back with the compound, which means I can't leave it at an angle because part of the compound will run into the part. Got to be very careful. Almost didn't catch it. That would have been very problematic. So we're just going to come in straight. Remember what I was saying about watching all your parts? Well, I was trying to face it and this wasn't sticking out enough. So I ended up touching this to the spindle. Actually stopped the spindle and ruined my beautiful face. Now I'm gonna have to reface it. Yeah, see, even I can't take my own warnings adequately. I did not even think of this thing running into it. I've never had that problem before. Amazing. Round 2 of facing the same side. That's embarrassing, huh? I give the warning and then I can't heed my own warning. I had to completely readjust everything to do this side cutting operation. This is a pretty delicate cutter. Kind of getting a crappy surface finish the first time, so I took too big a bite, so I reduced it down and we're off. Beautiful finish now. Now we're just going to flip the part around. This is perpendicular to this, and we can finish the other 2 parts and we should be good. Next up, we're going to bore a hole in the middle to meet up with this alignment pin so that it can self-center on the tool. That way I center my rotary table, and this will be centered as well. Just going to bore out the rest. And we're doing a test fit. How about that? That'll be pretty good alignment. All right, perfect. I also drilled and reamed the center of this for 1/4 inch. Will be alignment pin, and my +1 reamer is unlabeled, but it was supposed to be +1, but I think it's more like +2 based on that. That's kind of annoying. Anyways, we should be good. So my first solution was these guys. To hold parts in the rotary table that are larger than 8 inches. So they've got set screws here, and I can just snug these, and now this is locked in place. And I have to be very careful not to have these guys run inside this area over here, because it'll run into this. It'll also run into the brakes on the thing, so I'd have to take those off, and I'd have to be careful that I rotate this way around if I'm holding the part like this. So the part was going to sit on here somewhere like this, like right here centered, and then the clamp would come up here and press against itself and hold this part in place. And I can get both of these here and get them locked in, and that would work. But after dealing with this for a little while, I thought, that's not the ideal solution. So I went with idea number 2. Second solution involved using the rotary table. Got this guy centered in here. This is the one of these pieces. It's a Morse taper 3 that I just with threads, and I make these inserts that fit on the top that help you center a part. And this one will center this guy in here. I still need to drill 3 holes to bolt this to the table below it, but I got such a thick piece because I can machine this down and use it multiple times. So in this case, the part will sit, you know, roughly like this over the 1/4 inch hole, and then I will rotate this guy 90 and do this curve right here, and that should be really straightforward. I still need to do the bolt holes to bolt this guy down to the base of the table here. You notice this is larger than my 8 inch table, and that was on purpose so that I could hold the large part here. So that was the plan. So I need to do my bolt circle here, and the beauty is, since this is already centered about 0, my bolt circle is centered, so I just need to line this guy up directly with the x-axis here. I'll use my indicator to set that up, and I should be able to drill and countersink a couple holes, and we should be good to go. So these are lined up right over the T-slot, so I shouldn't actually be able to hit anything valuable. I actually was going to put spacers there. I just realized I'm not going to be able to damage anything because I should be on the T-slot, although that is not centered. Oh, that is centered, yeah. So we're centered right on the T-slot, so I don't need these spacers at all. I was worried I'd damage my table, but I don't have to be. The only thing I've got to worry about is this part rotating because it's not clamped down, but it's big and has a fair amount of friction. So I'm just going to hold it, and we're going to drill the first one and then clamp it and then drill the others. All right, we bolted this guy down. We will countersink after. All right, there are 3 bolts in here now. It's mounted to the rotary plate, and I've got them locked off. So now we'll loose it, and you can see we're all good to go. So you've seen me make these other pallets in the past, custom parts that sit on top of the rotary table to hold parts down. This was the mini pallet I made quite a while ago. And they're all really useful, but you'll notice they're all kind of small. I made this bigger one because the part I have to hold is so much bigger. It's still going to stick off over the edge, but this will let me work on it. They're all thick so that you can resurface them and, you know, put some features in them and resurface them. So I could take this button off here if I needed to, put something else, you know, reface this and have a, you know, a fresh one to go. So of course I'll save this after I'm done. But the next part of this is I need to set this to a known value like 0 or 360 or something where I can easily go 90 degrees. And then I'm going to machine off the whole half section of this down about 100 thousandths. So I've got a little lip that I can go up against so the part can be pushed up there and set really quickly. Rather than slot the whole top or relieve most of the top to create an inset for this to slide up against, I'm going to use this parallel instead, and I'm going to bolt it down. Right now I've got this part set so that it's perfectly parallel with the horizontal axis, and so that's perfect. So then when I rotate 90 and take this part this way, I can do the curve right here, and that will be centered around the axis. This is on the pin right now. Remember, I cut those pinholes on the bottom of this in each corner at the center of the circle, and I'm using that as my center rotation point. And so I've got to mount this guy on here, so I'm going to drill and tap and put it in place. First, I'm going to clamp this down because it's perfect right now. It's within 1/2 thousandth, which is more than accurate enough for this. And then we're going to drill and tap some keepers for this parallel here. All right, now we're good to go. I've got the fence in place. I can take the clamp off. I'm going to have to find another way to clamp this guy, but then I can lift this guy off, rotate it, and I should be able to find the hole over here. That's not going anywhere. I wouldn't even need to clamp this at all. I could machine this one right in place. That's pretty amazing. Maybe what I'll do is I'll come back and indicate the other side's in and just slide this over. There's plenty of play for that. I guess I didn't get those holes so perfectly oriented after all. Oh, actually, I know what the deal is. That's right. So this side and this side were correct. They were really tight, but they're correct. This one and this one's different because this is not perfectly square. It's actually slightly rectangular. I didn't try and make it a perfect fit, which explains why the fence is off for the other side by a few thousandths, like 5 thousandths. So what we'll do is we'll do these two sides, and then we'll come back and re-indicate and do these two sides. That'll work. Got to tell you, there's a crazy amount of work for some curves, but it's an interesting experiment, so I'm doing it. And I'm going to bump up the RPM, and we're just going to dial in a little bit for starters. Oh, I've already forgotten. It goes this way, right? Yeah, it goes counterclockwise. Got to get that straight. So I've got my 0 mark on the 90 here. So we're going to raise this up and go in. Oh, let's do 25 thousandths and see how that works out. And then we're just going to rotate. Currently it's kicking up quite a burr. My stopping point will be at 0 here. And the total depth you're supposed to go in is about 110 thousandths. And of course, we're all aware that on a CNC machine, this would be a trivial operation. I wouldn't be struggling like this. And I'm going to lock that off at 90. Remove my end mill. Hopefully, that turned out pretty good. All right, set up for the next one. That's pretty quick. And this bar is, the bar and the pin are essentially holding this part pretty well in shape. It can vibrate up a little bit, but it's so tight that it really doesn't go anywhere. And I just put my hand on it, and that seems to be pretty good. If I had made this base perfect size, I wouldn't have this problem, but I'm re-indicating in each side. And one little trick here is these are Belleville washers, which are shaped sort of like this. So when you tighten them down, they're a spring. These particular ones apply 60 pounds force. So I don't loosen them all the way up. And that way it holds this part way in place, so that it makes it really easy to just sort of knock this guy around gently and not have it move too far. and we're good. That one turned out better yet. Higher RPM is better. Well, the last curve I did at 40 some hundred RPM, maxed out my mill. Best finish yet, as you can see over there. So not all of them were perfect, but this part is done. So the base of the vacuum plate is now complete. Now this can be used as a vacuum plate all by itself if I want to use a part that's at least 8 by 8 so that I can get these gaskets to meet up with it. I could have put some internal gaskets, you know, to make for smaller pieces, but that's what the top plate piece is going to be for. The vacuum sucks the air out here through the NPT 1/4 inch hose there, and this part is finished. To glue the O-ring together, I used Loctite 380, which is a Renzetti favorite. Keep it refrigerated so it doesn't spoil, and it's called Black Max. Another one that you can use for O-rings is 401, and that one's recommended for plastic or rubber, so that one will work as well. That one might be a little faster, this one might be a little stronger. A couple things, I replaced the other barbed connection with a quick connect because that's much easier. What I really want is a 90, but I don't have one at this time. That's the NPT connection here. These aren't NPT, these are some other connection. So I'm going to need a right angle adapter with a different thread. Maybe I can find that, we'll see. I'm not sure what this little thread is. The O-ring material, getting the length was a little bit challenging. It should be stretched a little bit, I believe, to get it to fit the groove quite right. Otherwise it sticks up quite a bit. But you stretch it just a small amount as you're pushing around, it seems to stick. My corners were not as tight as some of the other areas, so I don't stretch as much in the corners. This Loctite 401 is better, I think, than the rubber reinforced. Not necessarily for strength, although it seems to be plenty strong, but because this instant adhesive is really instant, the other one is not. Also, it's very important to get square cuts with your O-ring material. And in order to do that, I found that if you roll the razor blade and the O-ring material while you're cutting, I'm trying to do this one-handed, but if you roll it while you're cutting, you get much straighter cuts. I was just trying to do straight down, and some of the rubber will stretch and it comes at an angle almost every time. But if you roll it while you're cutting like that, it seems to work pretty well. So those are a couple tips.